In this chapter, I want to look a bit more closely at coupling, how to resolve coupling, and then also start looking at how to move configuration away from the code that actually does stuff. So if we head over to the pre-Spring sample number 3, again we go into source main Java. We have our client class and also our service classes. Nothing much has happened here or changed here, except we've introduced this object factory class. We'll go into that in a bit more detail soon. But first, let's just recap what we've covered so far. We've learnt that coupling within our Java application isn't good, and we should be trying to strive or get towards loose coupling between our architectural or service type classes. We also understand that we're going to have some sort of coupling within our application, particularly within domain objects or model objects. We've learnt that programming to interfaces allows us to decouple or loosely couple our application code, making it easier to program, also easier to test. One other thing that creates coupling is the use of the new reserved word within Java. So if you see that anywhere in your code, you know there's some sort of tight coupling going on. If we open up the client class here, you can see now that I've replaced the direct instantiation of the concrete class to using this object factory. So why have I done this? Well, the idea is that we try to move the configuration of our application away from the part of the code or the application that actually does stuff. So here, what I mean by doing stuff is either running business methods or your application code. Here it's just printing a simple message out. But this part of the code up here is the configuration part. The advantage is that if you decide to change the configuration of your application, you want to use different concrete implementations, you can do. You can just inject them in. If you have a quick tour of the rest of the code, we'll go into the message printer service again. There's no instantiation of any objects in here. The basic implementation classes are pretty much the same as they were. We also have our interface here. The object factory itself is the only thing that concerns itself with actually instantiating objects. Now this separation of concerns is a fundamental aspect of inversion of control, and particularly for Spring. If we run our application, just do right click run as Java application, hello world, we can simply swap out the implementation here. Control-Shift-O, put the imports in, save, and run as Java application. And that's it, that's as simple as it gets. Now the reason for these 3 sample applications, each taking the stage of decoupling our application code, and also decoupling the concerns of configuration away from the actual part of the application that does stuff. This has a name, and it's quite a fancy name. It's called dependency injection, and it's a software design pattern. This term was first coined by Martin Fowler, and he has quite an interesting article on the internet. It's on Martin's website. It's at www.martinfowler.com/articles/injection. All it means really is that rather than hardwiring everything together using the new statement, we inject things. Dependency injection really is just a fancy term for passing collaborators in as parameters rather than hard coding them. And we've seen that through our examples. Gradually we've evolved the code from where everything's hard coded to being where everything's loosely coupled and injected in. Now Martin kind of specifies 4 key requirements to meet dependency injection. The first one being the implementation of a service object. Well, we have that here. We have 2 implementations. We have the basic message of the day implementation and our dynamic message of the day implementation. So that's number 1 met. The second requirement is the client code depending on the service. So we have a client code here. It's not actually this class called client. That's just the name I gave the class, but we have a message printer service, and that has a dependency on these implementations because it needs one of these implementations to actually perform its print message. so it's the client to that particular service. The third requirement is to have an interface that the client uses to communicate to the service. Well, here we have the message of the day service, which is an interface. So we don't talk directly to the actual concrete implementation. We always talk to an interface. And this has always been good design and practice within Java, programming to interfaces. And the final requirement is to have an injector object, which is responsible for injecting the services. Now you can either do this using the traditional sort of factory pattern, which is what I've done here. Not a particularly good example, but it's just to get the point across. Or to use what is known as a container. Spring uses the container concept rather than the factory pattern. So what you do is you specify in a configuration file all the classes that your application needs and requires. You can also then wire them together. In other words, associate which classes are dependent on the others so they can be injected in. Container handles all that for us. You can kind of think of dependency injection as kind of being identical to the strategy pattern, whereas the strategy pattern's a little bit different, where you can inject new implementations at runtime. Dependency injection does that really at build time, during configuration time, and then those relationships stay throughout the lifetime of the application. So I hope from these 3 sample applications it gives you an idea, an overview of how you can go from the way people traditionally program in Java to using more sort of best practices of programming to interfaces, decoupling, dependency injection, and using some sort of configuration object. Because now we have a good understanding of this, we can apply that knowledge to Spring, and we can see where Spring comes from. And that's what I'll be doing in the next tutorial. We'll start looking at Spring